Hi, and welcome to this reclass on setting up physics colliders on imported assets in Unity. This would be session 7 of the course Programming in C# and Playmaker in Unity. In this, we're going to cover importing an asset with animations, setting up a collision listener, the destroy action in Playmaker, adding rigid bodies to objects, as well as colliders, which colliders you should choose for different situations, just the basics of this, and disabling physics with rigid bodies. Alright, so on this last one we'll address this first. Why would you want to disable physics with a rigid body? Well, let's say that you want to have the collision or trigger functionality active on an object, but you don't want it to be affected by gravity, or you don't want it to be affected by drag. This is the reasons you would do this. So if you actually want to have some object like your player be able to interact with other objects, but you want to be able to actually control the object through script or through Playmaker actions, you would want to disable physics but still keep the rigid body, and we'll go in how to do that. Alright, so go ahead and close this, and we'll see relatively where we started in last class. We have Playmaker imported, and we have those nifty animals and their animations. First thing we did in last class was we created a cube, which we then shaped into something of a floor. I'm going to go ahead and zero this out, and then bring it into focus. Directional light, sure, why not? And we'll go ahead and use our tools up here. We have our move tool, rotate tool, scale tool. If you don't want to use the hotkeys W, E, and R. So W is your move tool, E is your rotate tool, and R is your your scale tool. Now, the reason I say this on such a, I wouldn't say advanced lesson, but a upper basic lesson, is because I see a lot of people still having trouble with these very basic things. Holding down Alt or Option if you're on a Mac to rotate around a scene. Holding down Alt and right-clicking to zoom out of a scene, or holding down Alt and middle-click dragging to pan around a screen. These are all very basic commands you should be familiar with. Alright, so what we did next is we used our scale tool to flatten this and then make it wider and longer. Alright, pretty basic stuff. Then we created a material. This material I'll call it grass, but you can call it whatever. Drag it onto the floor or the ground, and then up here in your maps you want to change it. Alright, you can see that if we click on this object, that grass is indeed the material that's been applied. Alright, so what we do next is we decide on an animal that will be prey, which will be the hunter or the predator. And I'm going to choose my trusty spider, and then I decide on an animal that will be the prey, or what the spider will hunt. And let's go ahead and choose, I don't know, let's do a pig. Now right away this doesn't look Although it does look realistic, it doesn't look like the spider would be able to do a whole lot of damage to this guy. Alright, so what I'm going to do is I'll use my scale tool to actually change the size of the spider. Go ahead and undo that. I'll change it uniformly with the middle cube or the middle handle. Okay. Now I can move my spider around, and now it looks a little bit more threatening to the pig. Alright, so next what we're going to do is we're going to add some functionality to this pig, and what we're going to add would be a collision listener. It's going to listen or wait for some kind of collision before it does any functionality. Wow, I never realized how freaky this spider is. Crazy. Alright. Well, anyway. So we have this pig, and let's go ahead into Playmaker, Playmaker Editor. When we're inside of Playmaker Editor, we'll right-click inside of this view and click Add FSM. We make sure that we have this state selected before we go and add some actions to the state. The actions we're going to add are simply collision event. Collision event detects collisions between the owner of this FSM and other game objects that have rigid body components. The system events collision enter, collision stay, and collision exit are sent automatically on collisions. Now, we're not going to use these system events. We're going to set up one on our own. We may get into system events, but it's exactly the same concept. It's just that you don't actually have to make the event. Alright, so we're going to use a collision event. It says it requires a rigid body. We'll go through some of the options first. First, we have the different functions we can call. We can say collision enter, collision stay, collision exit, or on collision, or on collider, controller collider hit. Now, the one we're going to use for this basic functionality is on collision enter. Collide tag simply says if this collision is only going to transpire, or only going to pick up or move to the next state if the collide tag, or whatever collides with it, has a certain tag. We're going to choose player because we only want this functionality to trigger if the player collides with it. Okay, so to set up tags, what you have to do is you select the game object you want to put a tag on. So we want the spider to be the player. And we simply go over here to where it says tag and choose the tag that it will have. Now you can go and add tags all the live long day if you would like. You can use the built-in tags, or we can add our own tag. We'll say my tag. Okay. And now when we choose spider, we can see that my tag is also included in this list now. But we're going to stick with the player tag. Well, to actually demonstrate that your other tags will come up as well, for this demonstration I'll choose my tag. And we'll go ahead and open Playmaker on the pig again. Alright, so the collide tag for this will be my tag. Now again, in class we use the player tag. I'm just trying to demonstrate that you can add your own tags to any game or any application and use it inside of Playmaker as well. Alright, so what store collider and store force, those are outside the scope of this initial lesson, so we won't get into those. Essentially, store collider will store whatever collider collides with this. In case you want to actually look for some functionality on the game object that actually collided with it. Store force stores exactly how much force this object was collided with. So if something's moving at a fast speed, you can store just how fast it was going inside of this. But again, this is outside the scope of this initial beginner lesson, and we won't get into it any further than that. Send event says what event do we want to send if a collision happens and the collider has the tag my tag. Right now there are no selections because we don't have any events, so let's make one. So I'll call this one something hit me, and this is a simple event that can transpire anywhere inside of this FSM, and we'll go ahead and do the send event something hit me if these are true. If there was a collision and the colliding object has the tag my tag, we will do the event something hit me. So to be able to actually do this event, we have to add it to the state as a possible exit of the state, which these are transitions. Alright, and then we have to make a state that this event leads into. So we'll just make a simple empty state for now, and we'll go ahead and connect these two. This first state I'm going to name a listener. The description, I'll say waits for some collision to happen with player. And this state, I will say this is a destroy self, which destroys the game object. This is a component of when a collision with the player transpires. Alright, so pretty simple functionality there. Alright, so the actions for this state, destroy self. I wonder if I can thin that out a little bit. I don't like that it's so wide. There we go. A little bit better. I'll do the same thing with listener. Okay, a little bit more manageable. Alright, so the only action we'll do for this event is simply destroy self. Now destroy self will destroy whatever object this FSM is attached to. Speaking of FSMs, I don't want to just leave this called FSM. I would like to give it a different name. So I'll go to FSM and give it a name. I'll call this collision listener. Alright, so now later on when we start working with multiple FSMs on a single object, I could easily cycle through and understand that this is the collision listener. If I were to add another FSM to this, for example, I'll make another FSM and I'll call this FSM movement. And say, for example, this FSM controls the random movement of this animal. Okay, and then if I want to go back to my previous FSM, I can easily cycle between them. Okay, consequently, you can use this to set up multiple functionality branches, more or less, for a single object. So we need to add a rigid body for this because collision enter cannot transpire without a rigid body or /and a collider. So let's go ahead and do that. Go ahead and close this, and we'll add the component. We'll go into collider, and we have a few ones we can choose from. Now, one of the things we wanted to get from this is collider selection. Now, box colliders are really what you want to use if your object is going to have some kind of walk animation and walk around, and you don't want it to be affected by physics. Now, the shape of this object is pretty much rectangular or oval, but if you want to think of the collider box outside of it, it would be rectangular. The spider might be a little bit different, but I would still just go ahead. I would either use a capsule collider or a box collider on this guy. The one that you really shouldn't use unless nothing else is working at all would be a mesh collider. This mesh collider is kind of a dynamic collider. It forms around the shape of your object. I'll go ahead and select it. Well, now you can see it asks you for a mesh. Now, if I were to drag the pig mesh, that's not the pig mesh, this is the pig mesh. Let's find it. Where is it? Pig mesh. And you can see the type of collider you end up with. The green is the collider. Lots of geometry there, lots of stuff you probably aren't even going to need. Alright, and that's going to be a lot of overhead on your system. Alright, so we don't really want to use a mesh collider for this. It's not necessary. Alright, instead I'm going to add a box collider. We can kind of, this green is not working. Hold on. Alright, so now we can clearly see the collider for this. Alright, so what we actually want to do here is we'll go down in this section and it says the center or the size, and what these are talking about are the size of the collider. What you want to do is kind of position the collider at the feet of the object. I guess I'll just leave that there. I thought there was a way to actually make that not show up. I know there's a way. I just have to research and find it. Alright, but that's getting sidetracked. Now we can kind of see here that, let's see if it's inside of here, because it's going to drive me crazy. Now we can turn that off there. Alright, so looking at the collider, we can see that the foot extends a little bit further down, so we can just adjust that in the y-axis a little bit. Takes up a little bit too much space on either side, so we can go and looks like the Z. Need to readjust that. And you know, you want to kind of think here. Do you want to include the tail? I mean, that's kind of something you want to change yourself. Alright. If you're having trouble kind of seeing side to side, you can change your camera from perspective to isometric, like this. And they're vastly different looks. Isometric's kind of what you want to use for any kind of 2D games. It takes the 3D aspect out of games. And you can see how close the spider looks to the pig right now. But if I were to turn on the perspective, you can see it's actually a little bit further away than what it appears to be. See the difference? Anyway, to line up colliders, usually your isometric is the best way to go. And then you can switch back to perspective. Okay, now with that done, I'll scoot this down. Now, the rule of thumb here is if you want this animal not to just fall through the floor, you want the collider to be above the floor, because that way it will fall a little bit and collide with the floor and stop. If you put the collider down through the floor like this, you're essentially putting the collider through the floor so that it will never actually make contact with the top of the object, so it won't stop. Alright, so with that in place, we can hit play, and of course the camera is completely out of position. Now the thing that I illustrated in class as well is lining up your camera. Now you can select the camera and move it in place yourself, and you can see your little camera preview here, and you can manually do all of this, and it's kind of irritating. You're not really going to get it right. I mean, you can get lucky, but the best way to do it is to set up the view that you want inside of your scene view. Select the camera and say Game Object, Align with View, and that will position the camera at your exact position when you do that with your exact rotation. So it'll have the exact same view you do. Now another use for this is maybe something you want to use later is, let's say I create a 3D object, a cube, and this is just a quick example. Let's say that you import some kind of weapon or something. You want to make a first-person shooter. I can position it here, and let's say I'm going to actually use my camera, and I'll say, okay, position my camera here. And I want this to be attached to my camera and extruding out of the camera so it looks like some kind of weapon. Well, you do the same thing. You select this object, Game Object, Align with View. Now if you rotate around, you'll see that the same thing happened with that object. Now you can take the object and move it however you see fit. And you can use your camera to kind of see where that object is. Maybe move that back a little bit, select the camera again, and you can see that this looks like some kind of firearm or sword or whatever, if that's the kind of game that you're going for. And then it's just no big deal to take that object now and attach it to the camera, so it will always be with the camera. If I could move my camera, you could see that it will always be right there with me. Alright, but getting off track again, I just wanted to illustrate the power of the Align with View command. Alright, so now I have my pig in position. If I press play, he will stay right where I positioned him. His collider prevents him from falling through the floor, but he'll never fall through the floor anyway because he does not interact with the physics system. Just because he has a collider does not mean he interacts with the physics system. He also needs to have a rigid body. And again, the rigid body is what makes it possible for collisions and triggers to happen. Without it, you will never have any kind of interactivity with this object as far as the physics system is concerned. Now if I hit play, the pig will fall down to the ground and he'll just go about eating his grass or whatever. Okay? Now, again, let's say that I want the collision functionality to happen, but I don't want this pig to be moved by gravity or by other physical effects. This is when these things come into play. First of all, the use gravity check and the constraints. Now, freeze position and freeze rotation are what you want to use if you don't want this object to be affected in any of these ways by the physics system. So if I push this pig with this spider, I don't want the spider to actually push the pig. Okay? Alright, so for example, I can raise this up, turn off gravity, and this pig is magic. He's magic pig. He levitates. Alright, so move this guy back down, and there we have our functionality. Another thing that I illustrated in class was over here, our new animation component with these animations built in. The spider only has 2, walk and death. The pig, he has a few more. He has idle, run, attack, death, walk, and hit. The one over here under animation is his default animation. So this is the one that he'll play until told otherwise to do so. So the one that plays as soon as I hit play. Alright, now if you want to change these, if you want to change the default animation, you want to select the one that you want to change it to, and then it will highlight it inside of your project. Then you can drag it from the project up inside of the animation section. Now if I hit play, he'll now do the run animation by default. Alright, conversely, I can change it to the walk, and he'll do the walk animation, or I can go back with the original, which was the idle animation. Okay? Alright, so that's it for this class, or reclass rather. Hopefully, if either you missed class or you have forgotten some of what we went over, this helped in those regards. Alright, looking back at my keynote here, we see we did go over importing an asset with animations. It's simple drag and drop, setting up a collision listener in Playmaker, setting up the destroy action in Playmaker, adding rigid bodies to object, simply clicking the component section. You can do it through this button, or you can go up to components and choose from this wide variety of things here. You can also just drag and drop. If you have a script and you want to attach it to some object as a component, you can just drag it over here. Okay? Where did it go? There we go. Adding colliders to object, rigid bodies, just went over that. Which colliders you should select. Again, try to avoid using the mesh collider at all costs, especially if you're working with mobile systems or you want to use a mobile system to test. And disabling physics with rigid bodies, and that was the part where we talked about freeze rotation, freeze position, and turning on or off the graphics, or sorry, gravity. Alright, that's it. Have a good night.